Let's try one more example, which is this instruction to add register EDI with the memory location indicated by address in register EBX. So once again, I just copy and paste it here, and we'll try to. So the pseudocode for this is to say EDI equals EDI plus whatever's stored in this memory. And of course, let's load register EBX with an integer, and how about we use integer temp1. So to be able to set EBX equal address of this integer 1 in memory, we can use move EBX offset, okay, offset of temp1. Right, okay, so let's see how this works. I'll just add some comment here that we're saying that EBX equals, and this is a comment, EBX equals address of temp1, right? So it's another C equivalent type of pseudocode. If we were writing it in C, this is how we would write it. If this was our pointer and this was the name of an integer, and we would take address of that integer and store it in EBX. Right, so let's verify that this works as expected. So we can again build and start our debugging session, pressing F5, and I will press F10 to move forward to this place right here. Let's set visible our registers. So here we go, these are our registers, and we're about to load address of temp1 into register EBX. So let's do that, F10. So this is now the address of temp1, and in our next step we're going to add EDI. So EDI contains this value with the 0 at the end, and we know that temp1 contains 1. So if this is the correct address, EDI should be incremented by 1. So pressing F10 one more time, you can see that EDI got incremented by 1, right? So 0 became 1. So this is working fine. Let's switch over to disassembly view, and again this is our last instruction here. So we're doing this. So this is our opcode 033B, and finally it matches the presentation slide encoding. And what is included in this encoding, again, there is an opcode, which is all the same adding instruction that adds 2 integers. We're using 3 because it's the direction and the size is 32-bit. And then we have mode RM byte, which has this value 3B, and of course we split these two together, and 00 indicates a 0-byte displacement, and 011 indicates the use of EBX addressing mode. Again, we can look up all this information in these two tables. These are encodings of the register in mode RM byte right here in this byte, right in the middle, bit fields 3, 4, and 5. And the other part is a combination of the leftmost 2 bits and the rightmost 3 bits. And from this outline, we can locate what it all means. And in our case, this is 00011. So 00011 indicates the addressing mode using EBX as address into our random access memory, and that's exactly what we have. So all of these parts can be found in these definitions, and this is how I found this EBX that of course confirms that this is the content of our mode RM register, and this is explaining to the instruction how to find these two things, how to find the destination of addition as EDI register, and that the source of the right operand of addition is something in memory, but the memory is accessed through address stored in register EBX.